The graph of a parabola is a collection of points that have the same distance from point to this here. We call it the focus. And let us name it as the focus F. Right. And here, this is a vertex of this at this point. And this is the directrix, this line, okay? And here is the axis. Hello? Owen and Brandon. David, Edward. Okay. So these are all the information we need to know about a parabols. Thank you, Miles, Jacob. So, and the equation of this parabola is x squared is equal to 4py, right? Here in this case, p is positive. If p is, so let us list all the information we need to know about a parabola. So here, the focus, right? Let us call it f, and the coordinate of this here is x squared is equal to 4py, then the focus here would be on the y direction, right? The y-axis. Therefore, oh yes, the x coordinate will be 0. And here, because p is positive, so it's pointing up, is concave up, right? So it would be 0p. Look at this. When p is positive, the focus will be in the positive part of y, right? So what else? The vertex of this, right? So let us call it V. It would be right here at 0, 0. Okay. And what else? The directrix. It is this blue lines here, and the equation of this will be? Yes, y is equal to negative p, right? This line. Very good. And furthermore, axis means this line, it is the y coordinate as well. So it will be the equation of x is equal to 0, right? So that is all we need to know about a parabola. How about if so another case, if p is negative, right, then the parabola will be concave down like this, right? And the same story, we need to know the focus, right? And what is the coordinate of the focus here?
0, 1.
Yes, it will be 0p, the same things, right? The vertex will be also the same here. The directrix will be also y is equal to negative p, but it will be p is negative, so negative p would be positive. Therefore, this line would be like this, and the axis would be similar. So that is all about the parabol. How about another case when
For the focus, is it B even if it's concave down?
say it again, please.
For the focus, is it 0p when it's concave up and concave down? Either way.
Here, the focus, it will be like this on the positive part of y, right? When it is concave up. But when it concave down, then p, f here will be 0p and p is negative. Therefore, it should be below the
Okay.
yeah, here, right? And similarly, if, look at this, if, so because here x squared, right? The equation of this is x squared is equal to 4py. So it is symmetry with respect to the y-axis. Because no matter positive or negative of x, it gives us the same value, right? How about if the equation y squared is equal to, let us say, 4px, right? Look at this. Y squared is a positive number, right? In this case, if p is positive, therefore 4p will be also positive. It means that the graph, the collections of points satisfying in this equation will be in the positive domain, right? And the same story, the vertex will be, if x is equal to 0, then y would be 0. It means that the graph will go through this point, the vertex here, right? And p here is a positive number, and the focus will be at here, p here, do you agree? The focus, let us call it f. But now, p is positive, therefore it should be on the right side of the x coordinate. It will be somewhere here. So the graph and the directrix will be at negative p, which is this line, right? And so the graph of this parabol should be somehow like this. Do you agree? But all we need to know is how it behaves. So then we find the focus, the vertex, the directrix, and the axis. So if p is equal to 0, then we see that the right-hand side here is simply y squared is equal to 0. It will go back to the special case when it is a line, right? That is a special case. It becomes a lot easier, and it is not a parabol. So that is why we only consider when p is strictly positive or strictly negative. Okay. Thank you, Alok. So, and the similar story. If p is negative, then the parabol will be pointing this way, right? But the directrix will be like this. Okay. So your job is to memorize these important things: the focus, vertex, directrix, and play with one specific example, memorize it, and it will be true for all the similar cases. Okay? That's it. It's all about the parabol. Then we move to another concept, ellipse here. Ellipse is a collection of points where the distance of that point to the 2 points here, f1 and f2, the sum of the distance from p to f1 and p to f2 is a constant, and we call it 2a, where a is a positive number, right? And for convenience, let us define a coordinate at the midpoint of f1 and f2, right? And here is the ox axis, and here is oy axis. Now, we're trying to write an equation of this. In a 2D, the distance formulas from P to F1 will be square root of x minus negative c. If we call this coordinate is negative c, 0 and c 0, right? And doing some algebra, we'll have that the equation of this ellipse will be x squared divided by a squared plus y squared is equal to 1. This is the equations of ellipse. And suppose, okay, suppose A is larger than C, A is larger than B. So here, look at this equation. The equation of this is x squared over a squared plus y squared over b squared is equal to 1. Now, this is the equation of this ellipse, right here. So let us find the x-intercepts and y-intercepts of this equation, okay? So x-intercepts, it means where it cut the x-axis and the y-axis. In the coordinate, in the graph, it will be this point, right? It means that y will be, yes, y will be 0, right? We plug into this equation. Let us call it equation 1. Therefore, from the equation 1, if y is equal to 0, then we have that x squared divided by a squared will be 1. Or in other words, x squared is a squared. Then we take square root of both sides. X will be plus or minus a. Okay? So the distance from the origin to this point will be a. And to this point, it will be also a. So in coordinate, it will be negative a right here. Is it clear? The same story. Let us find the y-intercepts. It means where it cut the y-axis, right? Let us find these numbers. Okay? The y-intercepts. It means that x will be, yes, x is 0. So from the equation 1, therefore we have that x is equal to 0, then the equation becomes y squared over b squared will be equal to 1. It means that y will be, yes. Thank you. Very good. So it means that this here will be b, this is negative b, right? Very good. So here, if we're given a and b, let us find c here, right? How can we find it? So in order to avoid memorizing too many things, let us take a look at this triangle, the special one. So if the distance from F1 to this point, it is this one, from here to here, and from this to the second focus here. And let us call this guy is the point A and M, and this is N. And let us name it in vertex V1. And at this point, we call it V2, okay? So look at this triangle, MOF2, right? Because the distance from the the point M to F1 and F2, the sum of the distance will be 2A. Do you agree? By definition. The distance of a point in ellipse to the two focus forces here, the sum of them will be 2A. But this triangle is special. We see that MF1 is equal to MF2. Therefore, this edge will be, the distance from M to F2 will be half of 2A, right? Which means A. Do you agree? You see it? So we see that MF1 plus MF2 is 2A, and MF1 is equal to MF2. Therefore, MF1 is equal to MF2, and it is equal to A. And this is a right angle. And MO, the distance of that is B, and the foci here, focus here, F2, we see that Pythagorean theorem, this is the distance is B here, right? And from here is C. So that is why we have the relation that B squared plus C squared will be what is it? Yes, A squared, right? If we're given the equation here, then it means that A and B are given. So we can find C, right? C squared will be A squared minus B squared. Because we assume that A is larger than B, then it is always true here. We can always find a C, right? C will be plus or minus of A squared minus B squared. So anyway, this is how we memorize the relation of this in ellipse. And let us summarize the important things we need to remember about an ellipse. First things, what is it? So we have that the foci will be, so in summaries, if we talk about an ellipse, having the equation x squared over a squared plus y squared over b squared is equal to 1. And we assume that a is larger than b. Then we have the relation that, so if a is larger than b, then this ellipse will be like this guy. If this is b, this is a, and here the ellipse will be like this. And the foci, suppose it is here, right? So the information we need to know is the focis. Let us name it F1 and F2. And F1, the coordinate of this will be, what is it? Negative C0, thank you, very good. And what is the coordinate of F2? C0, very good. That is the second thing, right? The foci. And so the x-intercepts right? Or in this case, we call it vertices. And we call it V1 and V2 here. And what is the coordinate of the vertices here? V1 will be It is this point, right?
Minus A0.
Thank you. Minus A0. Very good. Thank you, Walid. How about V2? Thank you, Mia. A0, right? And here, because A is the line segment from V1 to V2 is larger than the line segment from this point. Let us call it M and N here, from M to N. So we call this line the major axis. Okay. Okay, that is. And remember, because A is larger or equal to B, and from this triangle, you just memorize this relation here. And we know that the relation, in order to find C, we have that B squared plus C squared is equal to A squared, or C squared is equal to A squared minus B squared. Okay. That is one more thing we need to know. So since we can find C in this formula, therefore, yeah, we can find the 4C. I think it's better if we place it here. Okay. So, and what we need to know more is the y-intercepts. We call it the point M, or you can name whatever name you want, but the coordinate will be, what is it? Yes, 0, B, and in N, it will be? Thank you, 0 minus B. Okay? These are all things we need to know about the ellipse, and this, we call it the minor axis, MN, okay? Do you have any question about this? That's it, right? So here, when another case, if we are given the ellipse like this, the 4C now are in the y coordinate here. Let us call it like this. It's not a good ellipse, but imagine if, okay, it is perfect. Then the same story, to avoid the confusion between notation, let us call this times, we call it here is A, this is C and negative C. Here is negative A. Now we call this guy will be B and negative B here, right? So the same story. Now the 4C will be F1 at this point, and F2 will be this point, right? And this, the major axis now is in the y coordinate, in the y axis. So let us call it V1 and V2 here, and M and N here. The same story will be repeated. But now the equation here, it will be what is it here? A or B? At x is equal to 0, it will be A, therefore this guy should be A squared here, right? and here b squared. This is another equation of ellipse. But again, we need to know about the foci, the x-intercepts, the vertices, the major axis, the y-intercepts, the minor axis. Okay. If we're doing the test, then you need to list all these things clearly. Otherwise, you cannot convince the reader for problems. Okay. That's it. It's all about the ellipse. So now let us do another example. Go home and reread these theories, prove it. And now let us do the example here. Okay. Sketch the graph of this equation. Look at this. This is something x squared plus something y squared is equal to a number here. So we need to write it in terms, it is a form of ellipse equation, right? Some x squared. So how can we write it in a better way so that we can discuss it more clearly? The ellipse equation, it will be x squared divided by a squared plus y squared divided by b squared is equal to 1, right? So it means that we need to divide both sides by 144, right? It means 9x squared we divided by 144 plus 16 y squared we divided by 144 is equal to the right hand side is 1. Okay? Then use your calculator and compute here. So we can rewrite this one in terms of this, it will be x squared divided by, what is it? Thank you. Y squared, we can write it this way, 144 divided by 16 here, right? Is equal to 1. And after computing this, we know that 144 divided by 9 give us 16, right? Yes. And y squared divided by here, it will be 9 is equal to 1, right? We're getting closer and closer. So now let us write it in terms of x squared divided by something square, and it should be, what is it? 16 will be 4 squared, thank you. And y squared will be, 9 will be 3 squared, right? Very good. Now we have the equation, right? How can we graph it? Now, before doing anything, before pointing, let us get an idea of how it looks like. We know that what is the x-intercepts? So at x-intercept, y should be 0, right? Therefore, x will be? Yes, 4 and -4. So the ellipse will go through these points, okay? What is the y-intercepts? Yes, 3, 1, 2, 3. This point and this point, right? So 3, -3, very good job. And somehow we know that it should be, we guess, should be like this, right? So our job is to find the foci somewhere here, in between, right? So because here, the major axis is in x direction. So, and let us take a look at this one, this triangle, right? And remember, therefore, the major axis is in here. So let us define it A, B, negative B here. And this point should be C, and here's negative C, right? So by looking at this triangle, we know that the relation is, what is it? A squared is B squared plus C squared, right? A and B are given. And in this case, we know that before doing this, we know that A will be 4, right? And B will be 3, okay? So C squared will be A squared minus B squared, which is, what is it? Right. So C will be plus or minus square root of 7. So we know C, we know everything. Let us list all these things. So first, the foci will be F1, and what is it? Which is minus, yes. And F2 will be? So the foci we know, right? And the vertices, let us call it V1, it should be V2 is very good, great. And the major axis will be V1, V2, right? So, and the vertices here, or it is the x-intercepts and the y-intercepts. It will cut the y-axis at, what are they? Yes, 0, 3, let us call it, name it M, and N will be? Minus 3, very good, right? So that's it. That's all about ellipse, okay? Just memorize how, so first, try to write it in this forms and determine the x-intercepts, y-intercepts, and figure it out, okay? Then find the foci, vertices, major axis, y, and minor axis, okay? That's it. Is it clear? Okay. That is ellipse. Now, we go to another concept. Similar things. But here, the equations, we call it hyperbolas. And the similar story, the hyperbolas is the collections of points where the difference of the points, the difference of that point to the two forces, the forces here will be a constant. For example, Pf1 minus Pf2 here, let us call it equal to 2a or minus 2a. Then the graph of that will be like this, okay? Just look at this. And so we do some algebra using the distant formulas. And it ends up the equations like this. This is the equation of this parabolas here. Oh, I mean hyperbolas. Okay, but in this case, the forces, look at this. It is at F1 negative C, 0, and F2 C, 0. Remember, in front of this, we have a negative sign. X squared over A squared minus Y squared over B squared is equal to 1. This is the only difference between this hyperbolas and an ellipse, right? The ellipse, it is a positive, but here it has a negative sign. So it's very confusing. Look at this. Now let us take a closer look at this equation. Okay, let us copy this guy here. Bring it down below here and take a closer look at this equation. It's very interesting. First, from this equation, equation 6 here, what is the x-intercepts? The x-intercepts, it means that the y-coordinate should be, what is it? 0. In order to find the x-intercept, we simply set y is equal to 0. Thank you, Alok and everyone here. If y is equal to 0, then from the equation 6 here, we have the relation that x squared divided by a squared will be 1. It means that the same story, x squared will be a squared, right? Or x will be plus or minus a, okay? It means that the point V1 when x is equal to negative a, y is equal to 0. And the V2 where x is equal to positive a, y is equal to 0, which is these points here and here. Okay, these points. These points satisfying this equation, it means that it should be on the curves, right? It means this belongs to the hyperbolas here. Makes sense, very good. How about, can we find the y-intercepts? At the y-intercepts, it means that x should be 0, right? From the equation 6 here, we have that if we replace x by 0 here, we have that negative y squared divided by b squared is equal to 1. Therefore, y squared is equal to negative b squared, right? We know that b is positive, or b is anything, b squared will be a positive number. Negative b squared will be a negative number, right? But on the left-hand side, y squared is a positive number. Okay? If b is strictly positive, then this equation is impossible. We cannot find any y value that satisfies this equation, right? It means that there is no intercepts. Okay? But from this equation here, we manipulate it and we write y squared in terms of x squared. We see that y squared divided by b squared will be x squared over a minus here 1, right? Do you agree? Just subtract. So subtract both sides by x squared divided by a squared, and then multiply both sides with -1. We have this equation. From here, if we multiply both sides by b squared, what do we have? Thank you. Very good. B squared over a squared times x squared here minus b squared here, right? Then again, we take square root of both sides. Look at this. Okay. Because we see that x is always larger or equal to a. Look at this, right? It's always larger or equal to a. Therefore, this term is always larger or equal to b squared. Okay? Do you agree? It means that this guy subtract b squared is always positive. We have this relation. If it is positive, then it's okay to take the square root of both sides. And it should be plus or minus this guy, right? There are two cases. Look at this, it's a little tricky. But now if we take the limit when x approaches infinity, let us take a look at the first range, the limit of this guy. Right? When x go to infinity, then this limit is somehow similar to the limit of, so this constant here, we can neglect it, right? It approaches to, this equation is approaching to, and then it is neglected. So we can, it will be replaced this b squared over a squared x squared, right? Or it is the limit when x go to infinity of b over x, b over a times x here. Okay. And here, look at this. The equations the lines, the linear lines, b over a times x here. Can we go back to the figure? Can you follow it? Okay, look at this. This is this line. The red line, y is equal to b over a x, and here is y is equal to negative b over a x. Okay, so when x goes to infinity, the hyperbolas here will come closer and closer to these lines. Okay, that's it. So that is a quick introduction about hyperbolas, and let us write down all the information we need to know about a hyperbola. So suppose we have a hyperbola, and the equation of that is given by this guy. X squared over a squared minus y squared over b squared is equal to 1. So we know that let me copy the figure here, it's faster. Okay, it should be like this. Okay, very good. So therefore, the information of this parabolas we need to know is first vertices. And we call it, or the x-intercepts. So let us write x-intercepts here. It means that y is equal to 0, or we call it vertices. So the first vertex, we call it v1, and the coordinate of this, it will be negative a, 0, and v2, a, 0, right? That is the things we should know. And the y-intercepts, there's no y-intercepts. Right? And the relation. Okay? From now on, in order to graph this hyperbola, draw a rectangle. Here, this is negative a, this is a, okay? Suppose this line here is this guy, okay? We draw this rectangle. Like this. Sorry, we're not done yet. So, and here, so this point should be B. This point is negative B, right? If we draw this, then this rectangle here. So, and the relation here, C squared, is always equal to A squared plus B squared. And the for C, same story. F1, it will be negative C, 0. F2, C, 0. And we call these equations and y is equal to negative b over a x. We call it asymptotes. Y is equal to b over a x, and y is equal to negative b over a x. That is all we need to know about hyperbola. So tomorrow we will continue and do examples about this. In advance, take a look at the examples in the notes and try to do it yourself. I'll see you tomorrow.